Okay, for this problem, we're going to look at the summation of n equals 1 to infinity, 1 over 3 to the n plus 1, to determine if this converges or diverges. There are at least three ways of approaching this. And to be honest, all three work just fine. So take your pick. Method number one, we use the comparison test. Okay, now how's the comparison test going to go? Since 1 over 3 to the n plus 1 is less than 1 over 3 to the n, I've made the denominator smaller by getting rid of the plus 1. By making the denominator smaller, I make the fraction bigger. So this is less than this, and also summation 1 over 3 to the n converges. Why does that converge? Because that is a geometric series with the common ratio of 1/3, which is less than 1. Okay, so the nth term of this is less than the nth term of this, which is a part of the nth term of a convergent sequence. And therefore, by the comparison test, we see that the original series also converges. Yep, so that's method number one, using the comparison test. All right, second way of doing the problem. Instead of using the comparison test, we will use the limit comparison test. Let's see how this goes. Limit as n goes to infinity of 1 over 3 to the n plus 1. Now, what should I compare this to? Well, let's just sort of scratch work up here on the side, 3n plus 3 to the n plus 1. As n gets large, that's going to be something like 1 over 3 to the n. And so we'll compare this to 1 over 3 to the n, which is equal to the limit as n goes to infinity of 3 to the n over 3 to the n plus 1, just rearranging the fractions. All right, so limit as n goes to infinity. Let's multiply top and bottom by 1 over 3 to the n. And so that gives the limit as n goes to infinity of 1 over 1 plus 1 over 3 to the n. Okay, now what happens to this? This is going to be equal to 1 over 1 plus 0, because 1, 1, and then this part goes to 0 as n goes to infinity, and so that's equal to 1. The important thing is that it's a positive number that's less than infinity. And therefore, since summation 1 over 3 to the n converges, and the reason it converges is that it's a geometric series with r is equal to 1/3, which is less than 1, we see that the original series also converges. And it converges because of the limit comparison test. Okay, so that is a second way of going about solving this problem using the limit comparison test. A third way of solving this problem, which is completely acceptable as well, is using the ratio test. So method number 3. We use the ratio test. So let's take the limit as n goes to infinity of 1 over 3 to the n plus 1 plus 1 over 1 over 3 to the n plus 1. Okay, now we know that this converges, and so we're fully expecting to get an answer that's somewhere between 0 and 1. So the limit as n goes to infinity of 3 to the n plus 1 over 3 to the n plus 1 plus 1 Okay, now once again, let's multiply top and bottom by 1 over 3 to the n plus 1, or 1 over 3 to the n, pardon me. So that's the limit as n goes to infinity of 1 plus 1 over 3 to the n, all over 3 plus 1 over 3 to the n. And that's equal to 1/3, which is less than 1. So this goes to 1 plus 0 over 3 plus 0. So this limit is less than 1, and therefore the series converges. So therefore the series converges. Okay, before I move on to the next problem, so the root test is not going to work here because the nth power is not on the outside, so I can't use the root test. It is hypothetically possible to use the integral test. Integrating this is painful, 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 and so I don't recommend that.